Okay, the following geometric sequence is given: 243, then 81, then 27. 2.1, calculate the value of the fourth term, T4, of the sequence. Because this is a geometric sequence, it means that we are multiplying or dividing by the same number each time. So if you work this one out, you'll see that you're dividing by 3 each time. So T4 should be the next term, which is 27 divided by 3, which would give you 9. 2.2, determine the nth term, Tn, in terms of n. So we start by taking down the formula for the geometric patterns from the data sheet. That one is Tn is equal to AR to the n minus 1. We use this formula because they're asking us for the nth term. All you do in this formula here is you substitute your A value and your R value. Everything else remains the same. So A is the first term, which is 243, is substituted there. That's times your R value. Now your R value is equal to T2 over T1. So your term 2 is 81 over 243. Put that on your calculator and you're going to get your answer of 1 over 3. So your R is 1/3. Substitute that into the formula and your final formula will be Tn is equal to 243 times 1 over 3 to the power n minus 1, and that is how it remains. You cannot multiply 243 by 1/3. Okay, the following geometric sequence is given: 243, 81, 27. Explain why the infinite series 243 plus 81 plus 27 plus and so on converges. The word converges here needs to ring a bell with you. For converging sequences, you go to your data sheet. Next to your sum to infinity formula, you'll see R in between -1 and 1. So series only converge when R fits this, when R is in between -1 and 1. So we look at our R for this pattern. If you work out your R, which is T2 over T1, you get the answer 1/3. And now 1/3 does lie in between -1 and 1 on the number line. So it means that this is a converging sequence. The following geometric sequence is given: 243, 81, 27. Determine sum to infinity minus sum to n in the form ab to the power n, where Sn is the sum of the first n terms of the sequence. So sum to infinity minus sum to n, you just fill in both formulas here. The sum to infinity formula is a over 1 minus r, and your sum to n terms for a geometric sequence is a into 1 minus r to the n all over 1 minus r. All you do here is you need to substitute your a value and your r value into this formula. Your a, remember, is 243, the first term, and your r again is T2 over T1, which is 1 over 3. So wherever you see a, you put in 243, and wherever you see r here, you put in 1 over 3. So it becomes 243 all over 1 minus 1/3 minus 243 into 1 minus 1/3 to the power n all over 1 minus 1/3. We try to simplify this as far as we can algebraically and see where we come out. Remember, our answer needs to be in the form of ab to the power n. So the first fraction can simplify to 243 over 2/3 minus the second fraction there. We can open out the bracket by distributing the 243 into the bracket. So 243 times 1 is 243, then 243 times negative 1/3 to the power n will be negative 243 times 1/3 to the power n. All over the bottom subtraction there will give you an answer of 2/3. Now you see you have two fractions and you're subtracting. You must remember that when you add or subtract fractions, you need to find an LCD and put them together. The lowest common denominator here is already found. It's 2 over 3. So we can put these two fractions together. So it's going to be as the numerator 243 minus everything on the top in the second fraction. 243 minus 243 times 1/3 to the power n. Right, so we open that out using the distributive law, and we'll end up with 243 times 1/3 to the power n all over 2 over 3. This is once we put our like terms together. We can, if you look carefully, divide 243 by 2/3. We'll end up with 729 over 2, and that's going to be multiplied whatever's left, which is 1/3 to the power n. And if you look at this now, this is a times b to the power n, which is the form that they wanted.